Hi, my name is Bob Greenyer, and I'm a volunteer with the Martin Fleischmann Memorial Project. So thank you for joining me this 22nd of May, 2023, when I will be discussing O-Day, PROTO-SPHERA. So this is a follow-on presentation for the wind hex update for the third week end of May 2023, and I'll let some time for people to join the room. What you have on the screen there is the front cover of a 1950s wireless world. I actually bought it. It is the issue that has the key paper by one of the key colleagues of the kind of people that built the Integratron and who did the spinning pyramid work, which I spoke about recently. Hi, David Butilier. I don't know if you saw the previous stream, but it's good that you're here with us on this one. What year and what month? Let me get that for you. It is. Let me see. Where do I have it? I actually bought it. It cost just £15, but there is a digital version online which you can get. And I gave a link in my stream blog for this one. I can't find it right now. Why can't I find it? Hi, David Cooper. Hi, Space Case. Anyway, I'll come back to that. It was just any old slide I could put up there for the sake of having something that looked a bit like a sphere. So in the last presentation, I looked at this and I mentioned the Plasmac here, and then to link through, the Plasmac is an idea of something that is a version of a Spherimac. And actually, if you go to this patent-free way to make a control large-scale EVOs on the Martin Fleischmann Memorial Project from February the 5th, 2020, I have linked patent documents here to the Paul Collock 1973 patent and others, but also to this web archive link of a more recent document, and it refers to the main patent down here, 4023065. But this document is all rights reserved 2002 Prometheus 2 Limited. Prometheus is interesting. Remember, we saw Promethium the other day, it would appear, out of an Ultra experiment. So it's all tying in very nicely. We began investigating a potentially best workable concept for fusion in 1973. This is this patent. And have since continued that effort from just beyond the community's mainstream. The patent application described the compound plasma configuration, whose shared topology, this is the thing, was redesignated the Spherimac upon consultation with H.P. Firth. Initially, Spherimacs were experimentally formed within a rigid conducting shell, since a plasma conducting shell was too resistive, leaky, to work. Our continuing work in progress finally led to the all-plasma version. This is important. All-plasma version designated the Plasmac configuration. The physical embodiment is the hyperconducting Plasmac that has a fully compressible and impervious conducting shell that eliminates the wall problem and cyclotron radiation losses. Okay? What are we referring to? Something that started out with these kink instabilities leads to this domain wall, which they are then referring to as something that has a hyperconducting structure. I don't know what superconducting and hyperconducting is. Hyperconducting more superconducting than superconducting? Yeah? That has a fully compressible and impervious conducting shell that eliminates the wall problem and cyclotron radiation losses. This development, including formation experiments, is summarized, and Plasmac's important advanced features are noted. The conceptual and then physical formation of the Plasmac was very difficult to resolve. Eventually, the hypothetical solution, unlikely, conceived of a helical injection device, HID or plasma gun, that would result in the plasmoid's self-generation. Self-generation. Helical injection device, self-generation in an STP gas blanket. After a modification to the helical injection device, the plasmoid formed in the first series of 10 shots. The garage experiment was terminated with the first formation of the Plasmac, and we started the effort to build a blockhouse and experimental facility needed to contain whatever possible emanations might come from the continued low-level work. What possible emanations? Some of the evidence from that work is included herein. Our next step will be to produce Plasmacs of 25 centimeters in diameter with a lifetime of up to 1 to 5 seconds. Such Plasmacs could be inertially ram compression heated in a dense fluid blanket as a magnetized fusion target. Okay, so this is the structure of the Plasmac. You might have seen that in my presentations before. Magnetoplasmoid cutaway. And here are the formation principles, kink instabilities, joining together like that, all in a line. And you see it here. And these come together. The kink instabilities join together into one very, very intense torus in the center. It does not discuss the substructure here. Okay? And there we go. We have our main structure here. And that's what they're seeing it as in their experiments. La-di-da-di-da. And that is that. Okay, so what I'm arguing is if we can get charged toroidal structures and we shoot them in like this, their current, because they will be having this current loop, they will end up in a major loop and they will merge their power. And that's all in the pattern and stuff. Okay. Right. So I need to do something else now. And it's not here. It is here. What we're going to look at tonight is, and I will share a copy of the annotated version, is a document from the Italian Nuclear Energy Authority in Frascati from July 2001. But if you bear with me, I will get a video that shows that whilst this was what was being discussed back then, it is kind of one of the state of the arts in fusion research. So just give me a second and I will find the document that I'm referring to. Hopefully. Or maybe not. How is everyone? maybe I won't find this. Anyway, there's the tokamak, and you'll see that there are these more spherical type reactors. And if I find out where I put the link, I will get it for you later. But I can't find it immediately now. So that's a shame. Nope, I don't think I can find it. Okay, all right, well, I'll have to give that a break. No, I can't find it. What have I done with that? Okay. So, PROTO-SPHERA. I've got a whole bunch of links in here, but basically this is a proposal document that's given by basically one of the principal Italian nuclear energy authority labs by all of these people here. So this is a proposal by these four with contributions by all of these people. And it's quite a comprehensive document. The most investigated magnetic fusion configurations, tokamaks, are not simply connected a central post containing the inner part of the toroidal magnet and the ohmic transformer links and the plasma torus. The feasibility of simply connected fusion relevant magnetic configuration would strongly simplify the design of a fusion reactor. The PROTO-SPHERA experiment, spherical plasma for Helicity relaxation assessment, proposed at ENEA Frascati, would be devoted to the demonstration of feasibility of spherical torus, where hydrogen plasma arc in the form of a new screw pinch SP fed by electrodes. So this is similar to what you're talking about with the Spheramax and the Plasmac, specifically of Paul Collock. Fed by electrodes replaces the central conductor. The the screw pinch and the spherical torus have a common magnetic separatrix. Magnetic reconnections will occur at X points, injecting magnetic helicity, colloidal flux, and plasma current into the spherical torus. A spherical torus. What are we talking about there? Right, I'm just going to go. I've got a whole bunch of links here. So the first is, from the point of view of the magnetic fusion energy research, the PROTO-SPHERA project is in the framework of research of a compact tori, spherical torus, spheromax, field reversed configurations, FRC, and has the capability of exploring the connections between the three concepts. Okay, so it says here, spheromax do not use a transformer, as in tokamaks, to produce the nested colloidal flux surfaces required for confinement. Instead, spheromax are formed by the self-organization of naturally occurring magnetohydrodynamic instabilities. This is exactly what I was talking about in the Paul Collock work, which I was showing you just a moment ago. The self-organization means that there is not a unique way to make spheromax. Listen, there is not a unique way to make spheromax. This can occur in many systems. And indeed, several different methods have been successfully demonstrated, and there's a bunch of links there. Magnetic helicity, linked magnetic fluxes, plays an important role in forming and sustaining spheromax. So this is what I'm talking about. You get the kink instability, you get a bunch of them, they have the same configuration so that they join together and they concentrate the flux. An initial configuration with sufficient helicity and energy will spontaneously relax into a spheromax. So if you keep doing this, if you keep producing these things, after a while, it'll relax into this self-structured thing that, according to Paul Collock in that paper from the early part of this millennia, said it does not need to have this containment. It will have this boundary wall given appropriate boundary conditions. Figure 1.3 shows how a magnetized coaxial plasma gun creates a spheromax. Okay, so you get a puff of gas, then you've got this inner electrode and the coil here, stuffing field, blah, 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 blah. Spheromax formation, injection by plasma gun in a flux conserver. Okay, so this is creating a spheromax. And like I say, this is how they inject plasma into tokamaks, actually. Okay. It's well, not necessarily that hot, but this is used. So Simon Claret is asking, is this for hot plasma only? Define hot. I mean, there's a lot of different temperatures that plasma can be at. Okay, so SpheriMac, it's when you're talking about the actual temperature of the gas or the temperature of the kinetic motion of the ions and electrons in there. Okay. Anyway, so this is one way of making a toroidal and poloidal field in a SpheriMac. Okay. So that's the formation. Okay. So here, field reversed configurations is a compact torus plasma with a negligible toroidal magnetic field. It is never mentioned in here, but it will still have a toroidal moment. Okay, it might have a negligible toroidal magnetic field, but it will have a toroidal moment. Okay, that's my comment there. The next point here is time evolution of a separatrix radius profile of the flux function in a FRX. So anyway, the slow formation of a field reversed thing is using two merging SpheriMacs with opposing helicity, right? Two merging SpheriMacs with opposing helicity. And it has been demonstrated on SpheriMac merging facilities such as this one in Tokyo, this one in Princeton, and this one in Swarthmore. So, like, if you imagine what was being done by Bostic, he was creating kind of like a SpheriMac on one side and another side. So they're opposing each other, and they come over in a magnetic field, and they join together. Anyway, this is, in my view, like creating a minimum 2-Tor fractal structure. So like this, the 2-Tor fractal structure here. You've got them coming in from either side, one with one helicity and one with the other helicity, and it creates a SpheriMac with the poloidal flux. Okay, so it has one SpheriMac that way, one SpheriMac that way. These come together, and then you have the overall structure with the toroidal moment and poloidal flux as well. Okay. Okay. And an interesting observation is that the field reverse configuration plasmas produced in all experiments are more globally stable than ideal magneto-hydrodynamic theory would predict. Why? Why are they more stable? The field reversed configuration, magnetic configuration, has an ideal geometry for a future fusion propulsion using deuterium-3 helium fuel. So if you can get to the moon and you can get a lot of 3 helium from the moon, and you bring your deuterium on your spacecraft, then you might be able to get a very good plasma rocket out of this. Okay? This is a fusion propulsion system using deuterium-3 helium fuel using these field reverse configurations. So what they are saying is, if you can achieve a system where you have at least 2 SpheriMacs approaching each other with opposite helicity, you will self-organize into a field reverse configuration plasma, and that will be a Plasmac type PROTO-SPHERA, essentially. Okay? Are we making these? I wonder. Are we making them? I don't know. Maybe we are. Spherical tori. So what is a spherical tori? Oh, hello. Look at this. The spherical torus with A equals big R over A is less than 2. So we've got big R here over. So the radius of the big to the center line here is equal to that divided by 2. Okay, so that's the ratio. Okay, so the spherical torus is basically in the middle here. This one's got an aspect here of 1.25. This has got an aspect of 4.5 based on this calculation here. Okay, was proposed in 1986 by M. Peng and D.J. Strickler, Oak Ridge National Laboratory, USA, as a modification of the conventional tokamak, from which it differs because of a much smaller aspect ratio. Now, we have absolutely positively seen in Vega experiments torus, and we've seen them even having crenellated iron-rich boundary layer, hollow. And we have also seen horn torus or spindle torus, which would be this structure. 100% certainly, I can say we have created these field reverse configuration spherical tori in Vega experiments. Different in aspect ratio between a spherical torus and a conventional tokamak. Conventional tokamak here with your toroidal structure and the spherical torus. I can tell you right now that the most advanced reactors are moving towards a spherical torus. Why? Because it's far easier to make them work. You have a lot less effort than you have to do in a stellarator or in a tokamak to contain the field and stop instabilities occurring. Okay. Peng and Strickler pointed out certain advantages connected with low A, that's the aspect, concerning, for example, the high value of ratio between thermal energy and magnetic energy. This thing here can be achieved. So you get a high value of ratio between thermal energy and magnetic energy. No dedicated experiment along this line was built until early 90s. The first explorations of low aspect ratio configuration were made by modifying Spheromac experiments with the addition of a central rod carrying a current ITF to produce a toroidal magnetic field. So, where have we seen this before? I think we've seen this before. And I think we've seen this in a Henk-Uren experiment. Which Henk-Uren experiment, you're saying? I know that's what you're saying. Okay, let me see if I can get it for you. We have seen it, in my view, in this one. And I've copied the link. In Tungsten Chop Shop. Thank you, Henk-Uren. Watch out over here. Boom! It was that quick. So, I believe we have a metal wire, and this is tungsten wire, going through the center of this, what is, in my view, a field reversed configuration plasma, a ball of fire, a ball lightning type thing in here, and we know the current is flowing through because this is the anode. So the cathode is basically everywhere else. And because the metal of the chamber is also a cathode, but the main cathode is below, the closest cathode. And it's basically the current is going through here. So both of these are, in my view, effectively equivalent to the Plasmac. Okay? And here you can see some configurations. And these are different experiments with the wire going through the middle, Rotomac, wire through the middle, Spherics, Rotomax, wire through the middle, and this one with a big wire through the middle, but all trying to achieve what Henk was doing here. Okay? Very small experiment. Okay? Now, the magnetic lines of force in a conventional tokamak and in a spherical torus. Okay? So in the tokamak, it's all kind of spread out, and here it's like all the way through the middle. And our wire is going through the middle of this structure. Okay? The aim of the PROTO-SPHERA, the idea of the PROTO-SPHERA, spherical plasma for helicity relaxation assessment experiment, is to test a spherical torus where the central conductor current ITF is substituted by the current I driven by a plasma discharge, right? So this is around about 2001. This is about the same time that Paul Collock was actually doing this in his garage. It can be done in a garage experiment, which is exactly what Henk was doing. This central plasma discharge takes the form of a screw pinch fed by two electrodes placed upon the polar caps of the plasma sphere. Such a configuration has been devised theoretically under the name of bumpy Z-pinch or flux core spherimac. Okay? The scheme of the spherical torus, a screw plus screw pinch configuration. That, I believe, is what we've got here. But what they're proposing is exactly what was proposed by Paul Collock and actually done at around the time that this, or done before the time of this proposed paper. Okay? Formation of the toroidal plasma and the TS3 experiment. The formation of the spherical torus is obtained by the kink destabilization of a screw pinch through an increase of the longitudinal arc current. There we go. La 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 la, gets weaker, makes a screw pinch, then these merge together their magnetic field lines and they join together, right? Just what Paul Collock described in 1973. Schematic of a kink instability converting toroidal flux into poloidal flux. Toroidal flux here into poloidal flux, and then these link together, okay? And they do it and do it again. This is what I'm saying we will want to be achieving in the wind hex, and this is why I believe you will need charge in there at the very minimum, and then you will need to inject solitons with their poloidal charge, and they will be in line with each other and in the correct phase, and then it will accrete the power, and they will bind together and get stronger and stronger until it does the job. Sustainment of the toroidal plasma. The PROTOSPHERA experiment aims at sustaining the toroidal plasma after the formation through DC helicity injection. So they basically keep on feeding it with this thing that forms these kink instabilities. The physical scheme of the DC helicity injection is shown in figure 2.5 here. Okay. And can be summarized as follows. The plasma with open field lines intersecting the electrodes has this, therefore that. Because of the twist of the open field lines, the current between the electrodes also winds in the toroidal direction near the closed magnetic flux surfaces. Resistive magnetohydrodynamic instabilities convert through magnetic reconnections open current field lines into closed current field lines, winding on the closed magnetic flux surfaces. Magnetic reconnections necessarily break through helical perturbations, the axial symmetry, blah, blah, blah. So that's how they are keeping this thing alive, and that is essentially what is described by Paul Collock. Okay. Then it goes into the Helicity. Oh, hold on a minute. Where have we seen this before? Interesting. For two singly linked flux tubes. These are two singly linked flux tubes. Okay. Oh, we've seen these things before. A torus with this can be distorted into a figure of 8 in which lines of force appear not wound. Now, these are all from reference papers. The reconnection of two ribbons, both with winding number T1, it preserves the magnetic helicity. The difference in total magnetic helicity of the two configurations is independent of the field. Okay, right. What are we looking at here? I believe, and this is the paper that they are referring to, which is from 1983. 1983. So the topological properties of magnetic helicity. 1983 from Harvard University by Mitchell A. Berger and George B. Field. And that's where you're getting these diagrams from here. Topological properties of magnetic helicity. Figure of 8 shapes. A typical field line is shown. And here, these are the kind of things we have seen when an EVO from inside the supernova reactor somehow got and collided with the wall. We see these kind of structures formed out of the material that was carried with it. But here you've got this sort of Celtic knot here. And then you have instabilities forming and magnetic reconnection. And then you have one magnetic loop, another magnetic loop around the outside, and you have these figure of 8 loops, okay, which self-organize. Technically, that's an unknot. Yes, I guess it is. And we got some more down here. Okay. And there's, is it this one? Yeah, this is the other paper they refer to. And this is demonstrations of helicity conservation during magnetic reconnection using Christmas ribbons. And this is from 1989, 27th of October, 1989. And they're talking about how you do this and blah, blah, blah. Oh, there's that diagram. Two singly linked flux tubes. Okay. They can arrange themselves. We've talked about this before. They must arrange themselves. They can arrange themselves like this. There's our figure of 8s. Here is our knot here with another. So we've got our Celtic type knot here and another single loop here. And they're saying that this is not how these reconnect. This is an erroneous picture of flux tube reconnection. It doesn't work like that. It works like this. It breaks up and you end up with the maintained helicity in the loop here. Okay. Okay, so that's how you can demonstrate this using ribbons. Now, I don't know whether I want to say this here right now, or maybe I'll say it later. Let's see. Where was it? Do I want to say that here? This whole reconnection business and these whole squiggly lines, I think, explain some very, very interesting phenomena we saw. Bearing in mind that Paul Collock was going for a 25mm structure, or maybe it was a 25cm structure. But anyway, it was going. We have generated, Henk Uren generated a 15mm structure in his Vega experiment, amongst others, and we analysed that to quite some degree, and I'm going to pull it up now. If you give me a second. I probably actually put a link in here, have I? Oh, yes, I have. There we go. So, firstly, we talked about Dijkhuis, talking about these kind of structures, but that was in 1999. So, we've pushed this envelope all the way back to like 1983. Okay? But this is the 15mm ball lightning cut here. And why is this interesting? Well, when the adverts have finished. If you recall, we had this rather impressive structures forming. And that's another advert, so we'll kill that. Joy. So, if you recall, there was almost no effect and then 100% effect, where this spherical or hemispherical structure consumed or cut away this copper pipe. Okay? And if we zoom into that, like I say, it was essentially not melted at all. You can see here this 15mm spherical section taken out, slightly offset from this copper pipe. 100% effect and 0% effect. Okay? And when we look in there, even at this level where you are looking, this is 1.5 micron down the bottom here. So the scale down the bottom here is each of these ticks are half of a micron, right? So 500 nanometers. So these structures here are very, very small indeed. This is like almost 1 micron across. Okay? About a micron for these drilled holes. But in between, it doesn't look like the copper is melted at all. And it's all over here. So what I am now saying, I said that I thought that these were flux tubes. And here we go. I'm going to go in closer here. Maybe I can show you the scale here. So here, this is 1 micron here. So this is, this is 2 micron across, I guess, this particular one. And of course, these are nanometric scales in here. And this is like something like a hectagon or octagon. And then this is pointing into the viewer, into you. And this is off at an angle. And this is off at a different angle. So how I see these are a whole bunch of flux tubes. This is how I saw it. But this is a simple configuration. But it could be something more complicated, like you see here. Okay? And you've got a boundary layer here. And so inside the ball lightning in the boundary layer, it had a whole load of squiggly bits here, and there's a squiggly bits here. And what you're seeing is how it interacts with the surface. Not on this one. In the other one, when I can get it up. Here. Okay. Okay. Now, this has utterly profound implications, what I'm about to tell you here. Essentially, what I'm saying is that the entire boundary of our ball lightning is a whole load of intense linked magnetic flux tubes. Okay? And they are continually breaking and reconnecting and breaking and reconnecting. Maybe as there's more energy being generated or whatever. It's a continual process. What you are seeing here, I don't think, and I might be wrong, but has never been publicly demonstrated before. This for me was one of the most amazing things I saw last year in all of science. This consumption, 100% churning up of the material at nanometric scales. Meanwhile, over here, basically nothing at all on the copper. This is not this is not thermal. It could be magnetic, or is it fluxes of things that what cause magnetic processes, whatever. But there are flux tubes clearly here, and they self-organize in aggregate into a boundary layer, into what they call here a separatrix, which is able to consume the copper in this circular section here. Okay? Absolutely incredible. So this is with a different look at it. Okay? And I'm doing a sample here. This is a sample on this, and you can't see because I'm not showing you. This is a sample on this bit here. You can see here, and it's 78.5% copper with 21.5% oxygen. Okay? And on the structure that's in the core of this, it's 95.6% copper and 4.4% niobium. What? No, can't be. You know what I think? It's not got enough samples. I think it's probably just copper as well. So I can't believe that. It's just not enough samples, so we can ignore that. But it was interesting whilst it lasted. So essentially it's copper with a bit of oxygen there. Okay? Copper with a bit of oxygen. Okay? It's just cut the material. Now, why is this potential skin where you've got these fluxes of something that I believe are able to reconnect almost instantaneously as the structure maybe grows? Okay? What happens when you get two of these next to each other? Well, you get this. Give me a second. Okay, I'll do it like this. So I talked about this before, and I referred to the Dynamoes papers here, and also the Lugamer from 1996. But we've now pushed this back to 1983. Obviously, there's the Bostic 1957, and we've got the figure of 8 here with our counterflow fluxes. Okay, so I was suggesting back here that these kind of things that they were observing are a large structure of knotted flux loops that are forming here. But what I probably didn't make clear is that I think these things can reconnect, and they can reconnect instantaneously. And what implications does that have? I believe it explains this observation. So again, here we have our field reverse configuration structure here. Okay. Producing our our ball on the end of our wire. That the wire is carrying the current. This is from a 2001 journal by Sebastian Papasco and E. Loznieno in Fusion Research, Journal of Plasma and Fusion Research. Compared, this is their diagram with the positive and the negative, and this is the Henkurian Vega experiment. But this is what I think this explains. On the boundary layer, this layer where we have this fuzzy bit, which you can see here, this kind of fuzzy bit, this double layer, okay? On the actual separatrix here, the boundary layer here, I believe that we have what we are seeing in this. We have these flux tubes, and like it shows here, that these can break and reconnect. These can break and reconnect, okay? If you imagine the whole surface of this sphere is like that, and then you give it a little bit more energy, then two adjacent separatrix layers, their magnetic flux lines on or tubes that are on the surface that are all reconnecting all of the time, yeah, okay, they, with a little bit more energy, wet into each other. And the way they're wetting into each other is, like Ken Shoulders said, they can organize at electronic speed. So an exotic vacuum object is an electronic structure that can be made at electronic speeds. Yeah? So the wetting process here is effectively, probably, millions, billions, trillions of magnetic flux, or whatever they are. Maybe they're not magnetic, but they're certainly flux tubes of something reconnecting instantaneously. And when the power drops, they self-organize again into another stable structure. And here is just, I'm changing the contrast on this particular shot. And this was turning the power on. Okay, so all through this area. And this is what I believe was also going on in the Vega Valley. If you can imagine. You had in the channel the ball lightning forming. And when that gets intense, it will form it will flood out between the two pieces of brass on top of each other, and they will wet together. And it is a magnetic fluid. It's a magnetic fluid. So this absolutely has a relationship with magnetism, but the boundary layer is this thing, and it is this reconnection process, I believe, that gives you what's going on here. I don't think this is as clearly described as I have been able to do with Henk Uren's work to date. I think this is an important moment in plasma physics to understand the structure of the separatrix, the boundary layer between ball lightning and its surroundings. Okay, so moving on in this. Magnetic helicity, so we've done this and how that comes together, and they're injecting magnetic helicity in here. So, okay. So this is the reconnection of two ribbons, which we just looked at. This is this one. This is their helicity injection. Right. Relaxed states and compression. In order to obtain configurations of fusion interest, it is important to compress the screw pinch as much as possible. Okay? So they want to, by getting the, what do they mean by that? Well, if you look at the Paul Collock paper, if you compress the screw pinch, you'll get many, many, many turns, right? And the many, many turns will flux reconnect, and then the separate tori with their own poloidal moment will join into a very intense tori with very many, very much, a very intense magnetic field. Okay, and I was talking about in here at the beginning of the morning or beginning of the day, wherever you are in the world, where it was saying that they could lead to the poloidal rotation velocity would have to be extraordinary, and the stabilizing ring would have to be an extremely thin filament to keep the poloidal electron velocities well below the speed of light. The calculated energy densities within the filament would be greater than in a neutron star. Okay, so we are trying to get the screw pinch intense enough, and essentially what they're saying is to make this do fusion, you need to have a lot of these tori formed, which then self-organize into a very intense torus. Okay? Dynamo and confinement issues. In a plasma, the magnetic helicity is not conserved exactly, but is only dissipated at a lower rate than the magnetic energy. Magnetohydrodynamic plasma spontaneously relaxes to the lowest magnetic energy state consistent with the initial helicity inventory. The relaxation process typically involves magnetic reconnection as flux tube linkages are broken on the microscopic scale and then re-established in a manner consistent with helicity conservation. This corresponds to a form of current drive because a configuration that initially had zero toroidal current relaxes to a state with a finite toroidal current. Okay, so what they're saying is if you have a discharge like that, it has zero toroidal current. As it starts to kink, it still even if it has lots of kinks, they still have no toroidal current. Even if the kinks are going round and squiggling, like we saw in that Paul Collock paper, still no toroidal current. What you need is the flux reconnection and then all of those loops to connect together to create the suitable toroidal current. Okay. The effective electric field driving this current is called a dynamo field and results from the nonlinear interaction of fluctuating velocities and magnetic fields. At the present time, these processes are reasonably understood in an average global sense, but there is very little understanding of the microscopic dynamics. Well, this isn't necessarily about the... I think what they are completely missing is the fractal toroidal structure that this will form. Okay, they're always looking at this for a single toroidal moment rather than the fact that it could be fractal toroidal. And I think that they are also missing the fact of the potential for the potential for the kind of thing that we saw on the other YouTube, if I could find it, this one here, on the separatrix. Okay. It would be useful to demonstrate why helicity is conserved during small-scale reconnection processes. The dynamo model shows how fluctuating velocities and currents provide an effective electric field. A magnetic reconnection model can prescribe these fluctuations. The actual dynamics of reconnection are very complex and bring together many of the most difficult concepts in plasma physics. Well, it's nice when you can see it happening. It's nice when you can kind of see it happening. Okay? Comparison between Spherimax, which is the same thing as Plasmac to a degree, and Protosphere. Spherimax are usually formed by magnetized coaxial plasma guns used as helicity injectors in presence of a closed conducting shell. Okay, so this is kind of like how you put things into a tokamak type thing. The main difference with Protosphere, as far as the formation scheme is concerned, is the magnetized coaxial plasma gun formation requires breakdown in small spaces with extremely high filling pressures and kilovolt voltages. So when you're making a plasmac, that's what you need. This means that big amounts of neutrals and impurities are released from the gun. After the formation, the Spherimac is accelerated and expanded into a flux conserver. This means that the field errors already present in the gun are amplified. Okay, so it's highly compressed in this area, and when it comes out into the flux conserver, it is expanded. So you've got little errors down here, then they become big errors up here, which causes you problems. Okay, Protosphere will form instead at tokamak-like densities with very low voltages, 100 volts. And will not undergo any expansion because you already make them at the size you want them. Okay? And this 100 volts is of the same order of magnitude. It's in the hundreds of volts scale as what Henk was doing in his Vega experiments. And in fact, that's kind of what he is doing. He's creating a discharge, right, between a cathode and an anode in a whole environment. And basically whatever's made, that's what is made in that environment, right? Okay? The main difference with Protosphere, as far as the Q value is concerned, is Spherimac experiments have Q1 everywhere, and this means that there is too high magnetohydrodynamic turbulence can be present. Protosphere has instead tokamak-like poloidal field coils. So it makes its own field containment. Okay? Okay, the electrode experiment, they used hydrogen and helium arcs. The tungsten thorium alloy normally used in cathode where high current emissions is required has been substituted by pure tungsten. As a matter of fact, the temperature in the filaments rises to about 2,700 degrees C. This is an interesting temperature because this is the temperature at which 50% of the tungsten matter is able to produce relic neutrino-like cold neutrinos, according to Alexander Parkhomov. As soon as the arc starts and exceeds by far the thorium melting point of 1730 degrees C. So that's why they switched to just plain tungsten. The final relevant result is that the breakdown produced at low voltage, 100 volts, is in the same filling pressure range of a standard tokamak discharge, which is 10 to the minus 3 to 10 to the minus 2 millibar. Okay. So this is their configuration and rough schematic. And this is the actual apparatus here. So you can see this is something conceivably that could be done in not too big a lab, but this is Frascati. Okay, these are still serious players. Okay, and you can go and have a look at this. And this is the kind of structure that they are able to form. And this was at a current of 600 amps. Okay. So the volts are low, but the current is high. Volts are low, but the current is high. And here's a whole range of things here. So proto-pinch is where I'm going next. Okay, where are we? Okay. The main results of the proto-pinch test bench are the technical solution for 5 centimeter diameter electrodes are a directly heated AC tungsten cathode. So it gives the specifics here. I'm not really going to go into it. I don't think we need to do that. Right, 10.1. So there's a whole lot of specifics about this experiment and the type of anodes and cathodes here. These are like tungsten, mostly 95% tungsten and a bit of copper. And this is to protect the anode plasma injector. So this is essentially what was going on in the sapphire reactor. They had tungsten, iron, and kind of like or steel or whatever, and they have high pressure hydrogen going in, and it's proton conducting or diffusing through the steel component of this anode and leaking out through holes, and then the cathode was all the way around it. Okay, so it's kind of the same kind of thing, but they're effectively trying to build the ball lightning around the outside of it. Yeah. Okay. And it's many of them because it produces, as I showed you here, it produces little hemispheres on the outside. These are self-structured plasma, and they are what he has on the sapphire business card here. They weren't the first to do it, but they did the prettiest images here of the self-organized, what they called tufts. And then if you drive that harder, the tufts join together, just like the tufts are joining here together. Okay? And hence produce the same kind of thing in his apparatus. Okay? And so there's a whole load of specifics there. Magnetic reconstruction. In the flux core Spheromat configuration, like the Protosphere, the magnetic probes cannot be present in the whole of the spherical torus. So loop voltages and poloidal pickup coils must be located only around the plasma sphere. With this geometry of the magnetic sensors, it has to be clarified whether a magnetic reconstruction is still possible. In particular, with toroidal plasma current I be measurable in the absence of a Rogowski coil around the spherical torus cross-section. Okay? So they don't know whether they can measure the current is what they're saying, but they have to best hash at it. Okay. Now, this becomes very, very interesting here. And I think I've got another paper. Ejection of plasma toroids from twisted flux tubes in astrophysics. Right, we've basically finished the Sphera paper here, and we're talking about some astrophysics type discussions here. The purpose of this section is to show that in astrophysical gravity-confined systems, unstable twisted magnetic flux tubes are able to produce, through magnetic reconnection, helically twisted toroidal plasmoids. The fate of these toroids is to expand and to be expelled from the generating gravity-confined parent systems. In this process, the system is able to eject helicity and to shed a relevant magnetic flux with a negligible loss of mass. These phenomena bear strong resemblances to the formation of plasma in a PROTO-SPHERA. Now, what they're discussing here could be the means by which there is strained radiation, or the ejections in the Vega experiments of Henk Uren and David Lear. Yeah? Because what you're getting is, we are getting these balls, but they're getting too much magnetic flux within their capability to store them in that local area, and you get an ejection. And we've even seen this in a case where the ejection comes out, it actually comes out as two twisted pairs, just like as in Bostic's experiments, but it comes out of the ball. Sometimes it comes out as, looks like a little particle, but then it'll join another one that's coming round and orbit around it. Very, very much looks like, you know, we've already described where it doesn't have, when you're in this field reverse configuration, you don't have this toroidal magnetic field around it, but it still has this toroidal moment. So if you understand where I'm going with this, basically everything is lining up. What they are saying in this paper is, if you can achieve enough flux linkages of helicity to build into a significant enough toroidal moment, toroidal current, then you will get to the point of being able to do fusion. But I think that in addition to that, on the boundary layer, where they can wet together, like you're seeing here, there is even more interesting things going on the surface of the overall structure. Okay? So they're saying what we are doing and have achieved should produce fusion. And guess what? It seems to produce fusion and fission and everything in between. Okay? I think that the experiments that Dr. Takaaki Matsumoto, which he concluded were ball lightning, which Ken Shoulders concluded was ball lightning, which Winston Bostic said it was the basics for everything. It's basically ball lightning, which Roitzkiev is ball lightning and did transmutation, which Shoulders said did transmutation, which a sadly departed Takaaki Matsumoto did transmutation. We are creating not just the conditions for fusion, but for fission, for nuclear transmutation, and nuclear decay. And what I'm telling you in this presentation is we are creating the conditions that Frascati Nuclear Institute is saying you need to do this. But we are doing it at the lab level, same as what Paul Collock was doing around the time that this paper was being proposed. It's not just fusion, it's the whole smorgasbord of things. And I think that's because they are missing the fractal toroidal structure. They do not see it, they cannot see it because they've not seen the physical evidence that shows that that is what's going on. And yet, in the fusion research of Winston Bostic, he literally has an example where you create two toroids and you fire them against each other and they come into a toroid of toroids. It's a fractal structure. From the get-go of this entire research, they just don't Think about that. Even in this paper, it's talking about two coming together and forming a toroidal moment, okay? Or rather the dipoloidal currents and the toroidal currents. Okay. So, and then they are missing what's going on the surface because they've never seen this. They've never seen this. Something is going on where flux linkages are occurring. Something is going on where it can cut on the surface of the double layer. It can cut the steel. It can do wetting. They are magnetic flux interactions here. Okay, back to the astrophysics. These phenomena bear a strong resemblance to the formation of plasma in PROTO-SPHERA, but occur at magnetic Lundquist numbers which are much larger. This is in like interstellar type things than the magnetic Lundquist number of Protosphere, SE to the power of 10 to the 5, rather than 10 to the 8 to 10 to the 13. Also, the range of beta at which these phenomena occur span a much larger range of values, blah, 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 in the solar corona and in collapsing magnetic clumps inside giant molecular clouds. And this is for protostar magnetized accretion disks. Nevertheless, an accurate study of a laboratory plasma like the one of Protosphere could provide useful information on some of these phenomena, like magnetic Helicity ejections. We've already done it. We've shown the videos. Thank you, Henk. Thank you, David Buttilia. We've already done it. Another common feature to all these astrophysical systems is the presence of plasma motions in the form of torsional alpha-Venn waves, TOR. These waves act in many astrophysical systems, either being injected from the outside or being produced inside as current drivers. What you are seeing here right now is that in 2001, the Italian Nuclear Energy Authority is accepting that the system of producing fusion is related to what goes on naturally in alpha waves. They are saying that it's an electric type process, okay? Contrary to what some people would have you believe, that they don't consider these things. As obviously there are no externally applied electromotive forces in the cosmos. That's where the electric universe might have an issue. The drivers are convective forces pushing the fluid whose motion that deforms that. The deformed that creates this and induces that. Okay. Solar flares. And it goes on about solar flares. And here it goes. The coronal field has not an infinite capacity for the helicity, so the injected helicity must be ejected into interplanetary space. The corona plays the role of helicity channel, connecting the sun and interplanetary space. So you've got some emergent twisted flux from the solar photosphere rather. And here, and this is beautiful, X-ray toroidal plasma here. I don't know if you can see that. I'll zoom in. This is the X-ray. So they're looking at this with X-rays. EVOs produce X-rays, right? This is an X-ray camera, and they're seeing a toroidal plasma in the X-ray. X-ray toroidal plasmoid arrows here and here. Ejection, so it's coming off here during a LD solar flare observed from your core soft X telescope. So it's soft X-rays. This is the type of X-rays we should be seeing coming from an EVO. Okay. The plasmoid-induced reconnection model proposed by K. Shibata postulates that an unstable emerging twisted flux loop produces through helicity ejection by magnetic reconnection an X-ray toroidal plasmoid. And here we go. And do you know what this looks like? And I might have to show some diagrams, but this is the same kind of structure that I showed you on the ball burn sample, on the 1986 ball burn sample of John Hutchison, which is also on the European Space Agency's sunspots, where you have this thing that's offset at an angle, okay, and you have this other magnetic flux loop coming over here that produces this ejection of a plasmoid here, but in an X-ray. This one here. So this here, they are saying is this, and this is what we see on the European Space Agency, and this is also the kind of like the two center points with the offset thing in the middle, and I called it the sun cannot lie. Okay, so let me find that video. Why not? Okay. Get this for you. It's funny, we got a steady 33 viewers. Right. This is my video, The Sun Cannot Lie. I've received much mockery from this, but if you can see, we have these two fluxes. This is our sunspot equivalent here. And this is, sorry, and this is the off angle here. Now, does that look like, in any way, shape or form, what is represented here? Can you see it? Can you see it? Can you see it? Your off-axis bit here, which is these two here, right? And by the way, this has a yin and a yang and a yin and yang, right? This angled structure here. Okay? And this is this bit, and this is this bit. Okay? So, I would imagine that when John was doing this on the ball bearing sample, there were plasmoids being launched off the top of this. Ball lightning was coming off the top of this. And at the end of here, I show the European Space Agency image here mapped on top. So there we go. So you see the thing's off at an angle here. Then the two spots either side. Things off at an angle, two spots either side. There we go. So when I said that John Hutchison was creating the same thing and that it's scale invariant, because this is several times the size of the Earth, many times the size of the Earth, in fact. And this is not many times the size of the Earth. In fact, I think I even have it in my bag here. Let me see if I got it in my bag. I thought I had it in my bag. Maybe I don't. Yes, I do. There we go. Ta-da! There we go. That's the sample there. You can see the structure there. So you can see how big it is. It's about as big as my little fingernail there. Okay? So that is that structure there. And I believe that that structure there is that structure there. And that structure is producing a soft X-ray viewable plasmoid. And they're saying that this is the same thing, right? So, like, this is what they're trying to create, okay? This is the helical thing, you know, that's what they're trying to create, okay? All right. Now, this is interesting as well. So, in small-scale flares, the plasmoid collides and reconnects with the ambient field, generating a jet of torsional alpha waves, TAW, leading to X-ray jets and spinning is that hydrogen or whatever, surges. I don't know. But okay. So here we go. This is the ejection that we just seen here. But if it doesn't quite do it, you get this and it unwraps and you end up with a twisted ejection here of X-ray jets, which contains something else. I can confirm what that is later. This could be exactly what is going on when we are seeing those extraordinary emissions from Henk Uren and David Butler. Okay? Let's here. These kind of ejections here from various experiments. This is one of Dave's experiments here. You can probably see some squiggles here. So these were the first ones. Oh yeah, you can see them coming off. Let's try. Okay. Here. You have a ball lightning and then you have this squiggle coming off. Yeah. And this is in Ken Shoulder's experiment. Okay? So I'm saying that this one that came off, this ejection, is this. Now, if you can imagine that it's coming from the equivalent, if this, what does this here? What does this kind of gubbins? Yeah. What does this work? Okay. If that there, whatever does this, is on the so-called photosphere of our ball lightning, and bits of that break off, and it can do this to matter, okay, and it comes off as a beam, then it's not surprising that it's able to cut through this aluminium like this. It's doing the same thing that it did with that copper pipe. And I do believe it's like a subquanta, because when a ball lightning breaks up, it breaks up into lots of little ball lightnings. We've seen this in Rödskev's experiment, but we've also seen it in the Amasa gas on the 10 yen coin, where the subquanta of the subquanta ended up making the snowballs on cobblestones. So this is an ejection, and I think that ejection is very, very similar to this one, which is in David Butler's experiment. Okay. Here's another one from a Dave Butler experiment. Again, ball lightning, a toroidal thing coming off, beam. There's the actual structure there. Okay. Here's one in a experiment by Dmitry Baranov, okay, and it's left this track here, okay, and here's another one in a David Butler experiment, and it's essentially the same as one that was presented by Jean-Francois Geneste, former head of engineering, I think, at Airbus or EADS or something like that. But anyway, this is presented in 2010 and done by Claude Daviau. Okay, same thing. So this is in a very hard material here, but this is actually the thing that would cause this, in my view. And here is a whole bunch of them. And this is the example I was giving earlier, where you're actually getting the twisted structure coming off. Okay? Here's another one where you've got them orbiting around each other. Now, is this what is being described here? Where you get an EVO, effectively, which has toroidal moment unraveling and coming off in a beam. What we are talking about is explaining that what we have shown over the last several years is how the sun works, can be done in a garage by you for low cost, and it is demonstrating fusion. The transmutation we've seen is likely real. It is the same as ball lightning. And I believe that over the last few years, we have described the process with physical evidence superior to what has been shown in the literature, with the proviso that I've read so far. I would like someone to go out there and see if they can find the quality of evidence that we have shared here of these effective torsional alpha waves being emitted from experiments. Okay? Has anyone shown this level of detail? Has anyone shown the level of other types of things that we've emitted? Has anyone shown the proof, of this, of these that we've shown here? Has anyone shown the intent, the what happens at the surface? Has anyone shown the cutting at the surface? Has anyone shown the reconnection that I showed earlier, where you are getting these things reconnecting? I don't know where they're self-organizing. I don't know if anyone's done that. But to say that we are not showing how fusion works, we are literally doing what they hope to be able to do. We are showing what they hope to be able to do. They're speculating that this is what's occurred. You can literally see it in these in these videos. It's on video. This looks like a torsional alpha wave released because an Evo didn't quite make it out as a full Evo. Sometimes we get the full Evo coming out, an ejection like this. And that has been demonstrated by Henk Uren. And we've got the witness marks and the video of it actually happening. Okay? This is what John Hutchison did. It is the same as what's going on in the sun for the same reasons. We are creating, when we are creating these free-flowing, we are creating what is termed as a plasmac, which is a self-organized structure where you have a discharge between anode and cathode in a suitable environment with torsion put into it. Helicity, rather. So that it forces the production of the toroidal field with the poloidal field. Okay. And when you get those strong enough, they will do fusion. This is literally what they're saying. Okay? Protostellar flares. There is a growing evidence that the ejection of plasma toroids from twisted flux tubes could play a role in star formation processes. I think we've discussed this before, haven't we? By allowing a fast shedding of the magnetic flux from a star condensation region. Giant molecular clouds contain weakly ionized mass condensations of scale length 0.1 of a parsec. Called clumps, they are sites of massive star formation. The gravitational collapse of clumps is opposed by strong magnetic fields, by alpha waves, turbulent energy, alpha magna, blah, blah, blah. Magnetized clumps can condense via ambipolar diffusion of the magnetic field, which decouples the ionized component of the cloud from the self-gravitating neutrals. Essentially, what I was saying is that we are creating something that has the equivalence of things that are going on at the star formation level. Yes, that is what's happening. And here we go. We've got two things that look our birdies. I actually was going to do a whole video on this constellation and how it represents, our two structures coming together. Here, many moons ago, I was going to do on this particular constellation where you get like that. Like that. Yeah. Or like that. Yeah. You couldn't make it up. Magnetic pressure acceleration, centrifugal acceleration. This is the thing coming off. You're going to enjoy reading this. You're going to enjoy reading this. Okay? Solar flares. This one here. Protostellar flares. And burner parameters. Okay, here's the kicker. The burner parameters, the fusion performances of unrelaxed. So what they talk about is this. It's this paper. I won't go into it in detail, but it's Chandrasekhar-Kendall functions in astrophysical dynamoes, right? Blah, 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 blah. I think what they're looking at here is this is the separatrix magnetic field. It says that on the visualizations on the periphery of the domain at 3 times the scale and small scale magnetic field. Anyway, you can see how the magnetic field here is a big mishmash. You could kind of imagine how if you actually physically saw this interacting with matter, it might look like this. With this, kind of look like this. Maybe it would. Okay? Anyway, they argue that they are trying to create such a thing here. And you can look at the details here, but they actually do calculations here for what they would need in the burner parameters, as it comes to it. Yeah. In order to achieve fusion for different materials. Okay. And you can look at this in your own time, but there's a chart down the bottom here that might be interesting to look at. If I can find it. Okay. Oh, maybe I missed it. Okay. It's back in the burner parameters. Okay, the fusion performances of this are studied as a function of geometric size of the plasma. The nuclear burning is limited to the... Okay. The nuclear burning is limited to the spherical torus, which has the following parameters. Okay. Major radius 1 meter. Minor radius 0.8 of a meter. Elongations, la la la. So this is their particular design. And at some point in here, they tell you how much you would need to do. Okay. Deuterium-3 helium burners, and they give you the specifications here for it. And then they go on and do... That's all deuterium-3 helium. Then deuterium-tritium burners. And then I think they have one more. No, that's it. Okay. So basically, they are saying that this will do the job. I believe that this is what we are creating. I believe that because you see, when they are doing a reactor, when they're only putting either 3 helium in and deuterium, or deuterium and tritium, the only real option to squeeze that into a small box and get an energetic yield is to get fusion. But in our systems, like in the work of Takako Matsumoto, and in the work of Ken Shoulders, and in the work of John Hutchison, and in the work of Aretskev, and in the work of anyone doing ultrasonic systems like Suhas Ralkar, or in the work of Roy Shinamaza, or in the work of Yul Brown, when you're getting these self-organizing structures forming, but you're doing it on tungsten, or you're doing it on indium, or you're doing it on other elements, okay? You've not got the option, if it's tungsten or say copper or indium, of gaining a lot of energy by squeezing it into a small box by fusing. The biggest gain is to fission or to nucleon decay. Okay? So it's not surprising that that's what you get. So yes, it is using the same intense crushing, fusing it, pushing it into a small box. But if it pushes so much matter into a small box, at some point, it's got to basically collapse, and that is electronuclear collapse, as defined by Dr. Takaaki Matsumoto. And when you've got all of that prima materia, that I'm not any element whatsoever, then you can do fusion. And what do you get out of that? You get protons, you get helium, you do sometimes get tritium, and you do get things like carbon and oxygen. So it's first squishing it and into such a small box that it has to reorganize into things that occupy smaller space-time, and that needs to be, smaller atoms. And then if it keeps on going, it's got to do, as it says in here, neutron star-like pressures, as it says in here, that kind of same thing, and as was calculated by other authors, it does this neutron star pressure, then you get the total collapse of matter and then rebirth of matter, electronuclear regeneration. Dr. Takaki Matsumoto, thank you. Thank you for having the courage to show what you saw. Regardless of what people said. Thank you. I'd like to ask everyone watching to give a minute's silence. Okay. David, Hank, John, thank you. I don't know if you caught at the beginning of my last thread, I reached out to Shishkin to ask if I could better visualize his work with corals and Dubovik, and he wrote back and said, well, I can work with corals with you, but he said Dubovik is extremely ill. I said, would he be able to ask some questions? I've got some questions I want to ask him. And he said, no, he's too ill to take any questions. I don't think we're going to have Dubovik much longer. There are two other people in the field, senior people in the field. One's got a good prospect from his treatment in cancer. I can't talk about it. And the other one, not good. They have given their lives so that we might understand this. And a lot of the work can be done in garages. It really can. It has been done. Even by Paul Collock, by Henk, and by John Hutchison, by David, in different ways, by Tony Jaboni right now. We are doing this process, but it's not smashing little billiard balls together. We are working with nature. We are doing what nature wants to do anyway. All of the time, everywhere. Okay. I'll see if you've got any questions, and then I'm going to call it a night because I've got to do a lot of personal stuff next week. I don't know whether it's becoming clear to people, but I think really it's done. It's kind of like we'll only be able to look back on this and know that it's been done. No NDAs. Hi, James Vickers. Yeah, it's true. Scientific papers, despite the fact that a report found that over, I think it was 90% or something, couldn't be replicated even by the authors that did them. Well, I can tell you, our work can be replicated. Ultra can be replicated all of the time. And yet, there isn't a scientific paper on Ultra yet. Well, I mean, maybe Binger and Huang's work, but, you know, no scientific paper on that yet. But you can replicate it every time. Henk Uren's experiment, David Boutilier's Vega experiment, they basically do the same thing every time. Yep, that's replicatable. Yep. And I'm pretty certain that when the wind hex is running in the right way, that'll be replicatable. It'll do the same thing every time. This is why I'm focusing really on engineering applications of this technology, and you know, people can debate the other 130 or 150 theories and just get on and use it. I'm going to show you something in the next, well, like I say, I've got a lot of things to do next week. I've always got more to show you than I can possibly get through. But anyway, it'll have to take a break, and I want people to critique what I've put out today and maybe find connections or challenge things that's been said. But, you know, there are industrial processes out there that are using this process. David Buttillier is saying, have you ever spoken to Dr. Steve Greer? No, I haven't. Yeah, he does want open science to get tech out, but, you know, anyone can send him a video. Anyone. You know, David, yourself, that even working with a garage thing, it takes time and it takes money. And there's a lot of people that just want stuff for free. And that's okay. But someone has to do the work at some point. And it takes life. So, yeah. you got to strike a balance, but how many people buy coffee in a year and they could do with just one less coffee? Yeah, I understand he's working on disclosure. I'll be interested to see what happens next month. I mean, as I'm showing you here, this is an open access paper from 2001. It's a proposal. And it doesn't even mention at any point Paul Collock. Well, it might do in the references. Let me do a search. I'd be surprised if it didn't. But it might not do. And literally at the same time as this was going out the door, Collock had already basically done it. No result. There's not Collock is not mentioned in this whole paper, right? Now, is that because they are deliberately omitting Collock's work because he's at the same time publishing the fact that he is producing something that does this, or are they just ignorant? And that could be it. They could be ignorant. Shanjak, I accept what you've said there. The whole world tripped and fell through the looking glass in 2001. Yeah. There basically isn't a single aspect of the event I can't basically fully explain now. And it's this process. It's this process. Oh dear. What can you do? Yes, Simon Claret. The question is, do we care enough to act on what we know, or will we die thinking, I could have made a role, I could have played a role in making that happen. I could have played a role. But, I couldn't find the time. There was too many great series on Netflix or, whatever. I don't know. And that's okay. I mean, it's okay to enjoy life. Do what you want to do. I don't understand how there is, on the one hand, this pretense about wanting to solve these problems, and on the other hand, I mean, I do understand. Literally, I mean, it says it in this paper. It doesn't mention Collock. Right? And people that are only spending their entire academic life trying to fuse deuterium and tritium or deuterium and 3 helium together are not going to consider that if you had something that could do that, and it is this, what they're giving it a name, PROTO-SPHERA, right? Which is basically just a Plasmac, okay? Which is a plasma-driven, Helicity, helical plasma-driven, Spherimac. If they don't understand when they're in the field that can fuse matter, but why would it not break matter up? Okay, if they've got neutron star-like pressures in there, then it's bizarre. It's just bizarre. And then you got to think, well, maybe they do know that, and they are literally deliberately the very few that actually have thought about it long enough to think that, oh yeah, that is actually possible. They are deliberately stopping it from being a discussion point. And you might have noticed somewhere else that basically if no one is allowed to talk about something, it doesn't exist. It doesn't exist. But it does exist. You know? You can be the only person you know that has the truth. You literally can be. $1984. Look at this. 1984. Yeah. Simon Claret. They won't invest in this, but they'll tax you for breathing. Very good. Yeah. And that's another thing. DIY projects with charities, people don't have the time to see others' lives. No, they don't. They don't even have time to read other people's papers when they work in the same field. S. Martin 17773. We know people lie for their bread, paid not to notice or think about what they know. Yeah, absolutely. Absolutely. Hoaxing science by peer review negation. Daniel Foster. Yes, I agree. I have to give it credit to the ICCF 25 committee this year. They have accepted my paper on oral presentation. Now, if any other year is a guide to go by, I do expect my paper to be presented on the graveyard shift, which will be the last morning of the conference, probably early in the morning after the banquet the night before, which is normally the session that no one turns up for. And then I'll have a collection of people in the auditorium that will either say I'm talking too fast or I'm talking too slow, and they will cut me off. So I need all of your guys' help to like really hone this one to get it right, because we are literally doing what they say they want to do in this paper, and what is, you know, everyone's moving towards this fusion, and you can do it in your garage. You can literally do it in your garage. Don't know who that guy is. James Vickers says, perhaps the Action Lab YouTube channel would be interested in demonstrating some things. Should there be something which is easily demonstrated and understood in that format? I don't know, but most YouTubers are trying to go for... Let's put it this way. For 1,000 views, you might get, if you're lucky, $10 in ad revenues. So typically, they go for things that need to get 1 million views. So for every 1,000 views, $10. Every 10,000 views, $100. 100,000 views, $1,000. 10,000. If you get 1 million views, it's meaningful money. So that's what they're doing. They're not interested in something that's just like, oh, that's interesting, but like they want something that looks cool. That's the problem. Okay, all right. So James Vickers, this guy likes science and has a very large audience. I recommend the channel too. Okay. Some of it looks cool. Yeah. I think now it's pretty clear that we are creating the same effects that are the big effects that define how stars are born, how matter decays, how matter is born, alpha wave ejections, all these things. We've literally got them on video. And we've got, in my view, what ball lightning does in that left-hand part of the frame there. That's what it does to copper, you know, on the boundary layer. And we've shown all of these processes on video. I mean, the number of papers I see where, you know, you're just seeing a glowing thing, and it's like, well, it's a glowing thing. So's the light bulb in my house. It's like, what is it doing? And there's rarely any attempt to see that it's doing anything. And to be fair, what they're doing in these fusion experiments, they're trying to see whether when they put in deuterium and helium-3, or whether they put in deuterium and tritium, they end up with helium coming out. And ideally, because they like these kind of things, neutrons. Okay? They're not looking for physical changes to things which tell you a story. And that's what you've got right in front of you on this page, you know, on the left and on the right. I'll be interested to see how you do with your wind hex. I've got to call it wind hex, small wind hex. Henk's got a medium, but these are all relative to the bigger wind hex of Tony Gibboni, aka Rob, and even his is actually a small wind hex compared to the ones that are used industrially and were made by Frank Plifka. Okay, it is 2 o'clock here. If you can find it in your hearts to give a prayer for the families of Lion, I'll be speaking a little bit more about him in the coming week. Most certainly, I will try and find time for that. And for Dr. Takaaki Matsumoto's family. And if you can find it in your heart to find a prayer or a well wish for Dr. Dubovic, I would appreciate that. Thank you for all of your comments on Remote View, which I will pass to Dr. Matsumoto's family. And if people are interested in going to a celebration of Lion's life in the UK, there's only very limited places, so it needs to be people that maybe have played a role. Reach out to me and I can give you some details on that. It's coming up next month. So thank you very much for your time, guys. This was explaining several aspects that we have witnessed over the last couple of years in detail, showing that it is the same across many cosmological scales, and that we physically recorded these things both in matter, and we've analysed samples spanning from 1986 through to last year that show the effect. and that it is exactly what is being attempted by leading international fusion groups, and that it does much more than fusion. Thank you very much for your time, and I'll see you in the next video.